All right, well, let's get started. All right, well, let's. Okay, so I made this code a bit while ago that spawns in a bunch of particles, but it's really laggy. Like if I start drawing the FPS, it's probably going to be really bad. Yeah, that's what I thought. It ain't running that hot. So it's time for some optimization. So I've been wanting to get into Python multi-threading. So I heard there's many different ways. I've done the threading library, but I also heard there's something called concurrent features. So I kind of want to test this out. Let's see. Oh, so I could do something like this. So actually I could use threading. Import threading. And using threading, if we come down here, okay. Fine. Handle events. Event. Stuff. Event. Pygame. Event. Gosh, I can't spell today. There we go. And so we can just now shove all this into here. There we go. So this is going to be a single event. And so now I can just and I just messed this up. There we go. And this is supposed to go in main. I just messed this up horribly. Okay, there we go. And just wait for everything to update. Comma, started, colon, full, comma, radius, which is going to be an int, amount, which would be an int. Okay, let's try this now. Oh crap. Okay, so I think I may have to globalize these. Yeah, let's just set these up here with the particles. There we go. So now that this should work. Okay, it ain't working. So event equals keyed down. Honestly, I think it was just better when it was all together, so let's just put it back together. Okay, so let's just work on threading for now. So if I create a list of threads, and we can just leave particles.draw because that's fine, that's pretty efficient. The problem is, I think it's really not the update, I think it's the check collision and having to loop through every particle. So honestly, I may just do something like this and define check col for particle, and it's going to take a particle, and then it's going to, no, it's not going to check collision. Honestly, this thing needs to be renamed. This thing needs to be renamed to, is it refactor? No, rename symbol. It's going to be handle physics. There we go. This will take a particle. So where did it go? It's right here. Handle physics for particle, and so for other particles and particle, if particles not equal, handle physics. Oh, that may have been an issue we're having, because I'm not check. Oh no, I did check. Okay. So one, we could do particle.update, but then we can do threading. What does it have on this? Threads.append, and then 4 threads after thread.start. Start each thread. And if we wait for each thread, now let's try this. Let's see if this runs faster. Ugh, not really. It's still taking a while. So that's 500. And of particles. Radius will be radius. Okay, so what's going on with the radius? Oh, that's why. So this needs to go out one. There we go. So now the particles should not explode. Alright, so I want to update the draw square. Because you have the X and Y, but I want the distance between this. Okay, I'm not going to worry about that right now. Right now, I just want to worry about getting this. So what if we define the thread up here and then just start it every single time? Like Like, what if we define threads up here? Okay, let's try this. Threads can only be started once. Okay. Okay. List of threading dot thread. There we go. So now I have documentation. I don't think that's actually correct. Clock equals. But really, if we do clock dot get FPS and then set this to FPS, this should get more accurate. So once I spacebar this should start going. Yeah. I was gonna want to round this. How many particle up? We should only be doing a single particle update every single time. Like, okay, so we're running at 60. Then right when I hit space, it goes. Okay. Okay, I want to add something to this. So if I mod, where is it, mod 2 equals 0. So we'll define this, but I'm also going to add, so it's going to be x plus equals space divided by 2. There we go. So now it's, yeah, starts as a zigzag. So hopefully they should go a bit more random. Okay, maybe not. I really do not know. Sorry, this is irritating me that I don't know how many people are watching. Okay, probably the best way to do this is concurrent threading, I think. So if we change this to concurrent.futures, with concurrent thread, execute lambda p.update for particles. So can I do like for particle and particle execute? That's okay. There we go. Let's see how this does. Oh, okay. I still need like. This is still probably gonna be bad, but okay. So now, yeah, screen fill. Oh crap! I put this on the wrong side. This needs to go at the very top. Actually, just after the events. There we go. So now we're getting 12. So it's a bit better now. But we should be able to put max workers. And if I put 8, I wonder how well this will run. Now what if I just put this in here? There we go, do it like this. Okay, we'll worry about this in a little bit later. But right now, I just want to if play else do nothing. It's supposed to actually really what we should do is we should really do if play here. Always draw. Okay. So I feel like it's falling really fast, but okay. Trying gravity right now. 0.1. So I need the I need the normals, these. Okay, so I take the distance. If distance is less than push distance, we want to add a force to the particles to push them apart. So if we take if we take self dot x, it's, yeah, no, it won't be the overlap. It would actually be, it would be multiplied by 1 divided by the, no, it's not the overlap, that's the problem. It's not the overlap. This shouldn't work, because I'm already calculating this. So if we take self dot so to be, so we need to push them. I need to push, so like this particle needs to be pushed away from here and here. So we need the inverse normal. We need the inverse normal x. So if I take that and just add the self dot x is minus equal the normal underscore x times the if we do push distance minus the distance. Here we go, let's try this. Okay, that didn't work. Because the push distance is 10, so, but we max this at 1, probably. Because, hold up, I have to think about this. So, we want the push distance. No, crap. Get rid of this max. It actually needs to be plus. It needs to be plus the. So then it's trying to keep away. Honestly, what if we just do this? Like, just add. Actually, let's multiply. No, yeah, just add it. See how this goes. So if the distance what if I use push distance here? What if I do this? Nope, okay. Math is hard. So we have to use the normal x and with the minus of n, which we're doing. This needs to go away. Maybe that's my problems. Times distance minus push distance. So if we flip this, as the distance gets closer to the push distance. Here, let's see how this works. Oh, hold up. That's like what we want. Did I just figure out the math? That's not horrible, except for it being shot away. But we can probably change that later. Right now, okay, let's give it a shot with 400 balls. Okay. Hold up. Let's see. Because I'm dumb, and so I want to get another opinion. Thank you. Okay, so what's this thing? To optimize it. Divide the grid into a screen. Create a 2D screen to represent each particle. So. Okay, so. So we're going to do cell size is 20. So that means width and height is screen size divided by that. So define make underscore grid. No, that's not what we want. So we want, so yeah, it's going to be cells equal, which will be a list of a tuple. There we go. There's my make grid function. Make grid. So it's basically going to do for particle and particles. Yeah, if we floor it. Okay, I'm going to handle this differently. So I'm going to put particle.py, go to this test, paste this. Alright, that's irritating that I can't rename this. Oh wait, that's not even with the grid. Why is it so fast? Gosh darn. Oh, probably because I'm not clocking the FPS. Clock.tick FPS. Alright, so there we go. So now that I did that, let's go up to 10. Let's go up to 1,000. Even if my handle physics was very inefficient, I'm still keeping it because it's better. So what if I change this right here, this push distance? What happens if I set this to 50? It should try really hard to push them away. Alright, well, anyways, I'm going to end this stream because everything will be, I will probably code more tonight.